Hey there, 8th graders, and welcome to today's Explainer. So today we're diving into this incredibly cool math concept, coordinate plane translations. You know, whether you're dreaming of being a future architect, maybe a software developer, or honestly, if you just want to seriously level up your problem-solving skills, today's lesson is absolutely foundational. We're going to break down the exact mechanics of movement, and I promise you, it's actually going to be a lot of fun.
But before we get lost in the algebra, let's ground ourselves with this really powerful thought from Acts 17:28. In him we live and move and have our being. You see, movement isn't just some abstract mathematical concept, right? It's a core part of our physical and spiritual reality. It's really a fundamental truth of how we exist in the world. So as we look at how to move shapes perfectly and consistently across a graph today, keep in mind that understanding movement actually helps us understand the amazing order and structure of the space all around us.
All right, let's look at our roadmap for today. First up, we've got moving through space, followed by the rules of translation, and then we'll run through some step-by-step examples. After that, it's your turn to practice, and finally, we'll wrap up with the Godly Learner philosophy. Let's dive right in.
Starting things off with Section 1, moving through space. This is really the big idea behind translations.
So what exactly is a translation? Well, it's essentially just sliding a shape from one position to another. But here is the absolute crucial thing to remember. You're doing this without changing the shape's size or its orientation. It doesn't turn, it doesn't rotate, and it certainly doesn't grow or shrink. It literally just slides. And honestly, this teaches us the incredible value of absolute consistency. Because no matter where that object is moved on the grid, its fundamental identity, its size and shape, stays exactly the same.
And listen, this is definitely not just some math drill to keep you busy. Understanding translations builds vital spatial awareness. Just think about the careers and technologies we're looking at here. If you're designing a building in architecture, you have to slide structural elements precisely. In robotics, you're programming machines to move along very specific paths. And video game development? This is a big one. Every single time your character moves across the screen, the game's code is basically performing a rapid-fire translation. Even just navigating a graphic on your GPS involves this exact kind of mathematical shift. So yeah, mastering this builds a super sharp attention to detail and direction that you're going to need in almost every modern tech or design career out there.
Which brings us to Section 2, the rules of translation. Time to decode the math, so definitely get your pencils ready.
All right, here is exactly what you are going to be fully empowered to do by the time we finish this explainer. You're going to be able to easily identify a translation on a graph, use specific algebraic rules to execute these slides, and then clearly describe those movements using both descriptive words and precise coordinates.
Now, what's really interesting about this is how simple the formula actually is when you break it down. Think of this as our master rule. You start with your original coordinate, x and y. That little arrow right there, that just means translates to or moves to. To find your brand new position, you simply add an a value to your x, which tells us how far to slide left or right along that horizontal axis, and then a b value to your y, which tells us how far we slide up or down on the vertical axis. It really is just a beautiful, highly predictable set of instructions.
Let's move to Section 3, step-by-step examples. Let's see how this all builds as we do the math together.
Okay, in our first example, we want to slide a point to the right and up. Imagine you're starting with point A, sitting right there at the coordinates 3, 2. Our master rule for this specific translation is x plus 5 and y plus 2. So what do? We simply take our starting x coordinate, which is 3, and we add 5 to it. Boom, that gives us 8. Then we take our starting y coordinate, 2, and add 2 to it, giving us 4. Just like that, point A has safely and consistently slid to its new home at coordinate 8, 4.
But what if we want to go the opposite way? Let's check out example 2, moving left and down. We're starting with point B, way up at 6, 7. Notice our rule this time actually features subtraction, x minus 3 and y minus 4. Now subtraction in our master rule simply dictates movement to the left on the x-axis and downward on the y-axis. So 6 minus 3 gives us a new x of 3. 7 minus 4 gives us a new y of 3. So point B has beautifully slid down and to the left, arriving perfectly at 3, 3.
All right, now for kind of a special case here in example 3. What happens if there is literally zero vertical movement? Let's start right at the origin, point C at 0, 0. The rule is simply x plus 2, and, well, the y is just y. It's left completely alone. Because we don't add or subtract a single thing from y, that vertical position does not budge. We strictly shift the point 2 units to the right on the x-axis. So 0 plus 2 is 2, and the y stays a big old 0, meaning our new point is 2, 0. Simple, right?
And now for my favorite part. Section 4, your turn to practice. Let's tackle these homework challenges.
All right, here we have 3 points, D, E, and F. I challenge you right now to calculate the new coordinates for each one. For point D, starting at 1, 5, we're applying the rule x plus 4, y minus 3. Go ahead and mentally add 4 to that one and subtract 3 from the 5. What do you get? Okay. Now for point E at 6, 3, apply x minus 2, y plus 1. Have you got it? And lastly, for point F, you've really got to pay close attention to that negative number. The starting y is -1. When you apply y plus 4 to a -1, remember those integer rules. Just take a quick second to map out exactly where these points are going to land. Okay, let's flip the script a bit and test your deeper understanding. Instead of me giving you the rule, I'm going to give you the start and the finish line. If you start at point G, which is 7, 2, and you somehow end up at a brand new point of 2, -1, well, what was the master rule that got you there? You got to ask yourself, how do I get from an x of 7 all the way down to an x of 2? You'd have to subtract 5, right? So your x rule is x minus 5. And how do you get from a y of 2 down to a -1? You'd subtract 3, so your y rule is y minus 3. Put it all together, and the complete rule is x minus 5, y minus 3. See? You're essentially working backwards.
Now, so far, we've just been sliding single points. But what about an entire shape? Imagine a triangle that has vertices at 1, 2, 2, 4, and 3, 2. If you apply the rule x plus 3, y plus 2, what are the new coordinates going to be? Well, remember our core definition of a translation. The shape does not change size. So all you have to do is just patiently apply that exact same rule to all 3 vertices, one by one. You just add 3 to every single x and 2 to every single y. And when you do that, the whole triangle slides perfectly across the coordinate plane in total unison. It's actually really satisfying to see.
Let's zoom back out for our final segment, Section 5, the Godly Learner Philosophy. You know, here at Hero Smart Academy, we strongly believe in intertwining our education with biblical morality. So the crucial takeaway is really this. Education without morality ultimately leads to bad choices that end up hurting people. Think about it. What's the point of being incredibly smart, of knowing exactly how to translate a shape on a coordinate plane, or coding an amazing video game if we are supposedly educated, but we just keep making life choices that damage ourselves and the people around us? A purely academic mind just isn't enough. However, when you cultivate a spiritual mindset right alongside your education, that protects you, and it leads straight to the promise of genuine peace of mind.
And that honestly brilliantly illustrates the promise we find in Romans 8, 6 through 7. It literally guarantees peace of mind to everyone who keeps their mind spiritual. As you engage with mathematics, spatial awareness, and these exact rules of movement we've been talking about, you are literally seeing the order of creation. True peace is just the natural result of engaging with all content, yes, even algebra, through a spiritually grounded lens. It brings total harmony to what you know, and more importantly, how you live.
So I want to leave you with this one final thought as we wrap up today's explainer. You are gaining some truly incredible skills today. Math skills, logic skills, spatial awareness skills. So the question is, how will you use your education and your newfound spatial awareness to build a life that brings peace rather than hurt? As you learn to navigate this mathematical coordinate plane, I really encourage you to also carefully navigate the choices in your own life. Keep your mind spiritual and keep moving consistently toward the good. Keep practicing those translations, and I will see you next time.